Welcome to this deep dive. We are so glad you are joining us. Our mission today is to unpack a really dense multi-omic systems biology paper about the bowtie framework of aging. Okay, let's unpack this. Researchers are actively transforming a static biological model of aging into a predictive AI-driven diagnostic test that can actually forecast your future health trajectory.
It really is a massive leap forward. I mean, systems biology is taking the abstract concept of getting older and making it mathematically predictable.
Yeah, and to really understand how this AI works, picture a literal bow tie. On the left side, you have this wide edge of environmental inputs coming into your body, and that funnels into a narrow knot in the middle, your biological pathways.
Right. And then it fans back out on the right into the wide edge of aging outputs. If we connect this to the bigger picture, those inputs on the left used to be just vague categories like diet or microbiome.
But the new AI model makes those inputs incredibly precise, right?
Exactly. We aren't just looking at a general microbiome anymore. The data specifically looks for a rejuvenated gut dominated by highly specific bacteria, mainly Actinobacteriota and Bifidobacterium.
And diet gets hyperspecific too. The paper looks at how something like eating yogurt regularly compounds over time. It directly tunes your lipid metabolism, optimizing your HDL and VLDL cholesterol levels. But it's not just what you eat, is it?
No, it's how you live. That is a crucial point. Things like socioeconomic deprivation and household income are plugged directly into this model because they physically weigh down your epigenetic clock.
The AI sees exactly how your social environment translates into molecular aging, but here's where it gets really interesting. All those wide inputs funnel into that narrow central knot of the bow tie.
The filter where your body makes its critical decisions about how to handle stress.
Exactly. And the researchers introduced AI to calculate a causality factor, or tau. How exactly does that work?
Think of tau as the AI's way of judging intent. It weighs whether a biological change in your body is harmful damage or if it's actually a beneficial adaptation.
So it provides mathematical proof that not all changes in your system as you age are bad. It's separating the wear and tear from your body's defensive upgrades.
Right, and it's not just chemical. The model tracks physical mechanical stress through something called the YAPTAZ signaling pathway.
I read that and immediately thought about how I feel my own mechanical age after simply sleeping on my neck wrong.
It's a great analogy, actually. The YAPTAZ pathway shows that your vascular walls literally sense structural stress over time.
So your blood vessels are physically feeling the years go by, and the AI measures that mechanical aging alongside the chemical changes. That blows my mind.
It is incredible. So moving to the right side of the bow tie, the outputs, this is where the AI really flexes its predictive muscles. What's fascinating here is how the AI uses that central knot to split those aging outputs into two separate epigenetic clocks.
Damage and adaptage. Let me make sure I have this straight. Damage tracks the obvious detrimental stuff, molecular scars from smoking or too much sun exposure.
Yes, and adaptage is tracking those protective modifications we just talked about.
So a higher adaptage score actually means a lower mortality risk.
Exactly, and the precision is staggering. To measure this, the model looks at markers like DNA methylation instability, or DMI.
Basically checking to see if your normally stable genes are starting to behave erratically. I also saw CHIP mutations mentioned in the notes. What are those?
CHIP mutations are early genetic precursors to leukemia that accumulate in our blood as we age. The AI tracks them as a key metric of accumulated damage.
But it balances that by looking for protective factors, like a newly identified 37-protein centenarian signature. That signature includes the AK1 enzyme, which regulates cellular energy balance.
Right. It basically keeps the protein levels of a 100-year-old functioning like someone decades younger.
So what does this all mean for you listening right now?
Ultimately, this AI test measures your biological resilience. The old assumption was that extreme longevity meant keeping your body perfectly pristine with absolutely zero biological damage.
But the data proves that's simply not true. Wait, so you're saying the AI shows we can carry all this cellular damage, like the CHIP mutations, and still be healthy?
That is what the data is pointing to. If you have the right regulatory conditions like a highly tuned microbiome and a strong adaptage score, you essentially decouple aging from disease.
You can carry that damage without collapsing into frailty. It's a complete paradigm shift. We're moving from a medical system that just treats geriatric decline as it happens to using AI to actively build extreme longevity.
It changes the focus from just stopping the clock to building up your body's tolerance to time.
Before we wrap up, I want to leave you with one final thought from the paper. Aging ultimately causes what researchers call physiological complexity loss. Basically, as we age, our internal systems lose their intricate flexibility.
Variances in your beat-to-beat heart rate are actually an early warning sign of this physical collapse.
Exactly. So, could the everyday smartwatch you wear on your wrist right now soon predict a critical shift toward frailty before you even feel a single symptom? Something to chew on. Thanks for diving deep with us today.